Hi guys, in this video we're going to be looking at how to read a scale, which is a skill that's used in many areas of maths, including when reading number lines, but also, perhaps more importantly, when reading graphs. Now, when we're presented with a scale, such as these ones here, the number one question we should be asking ourselves is, what are the increments? What does the scale move up in? Now, there's a couple of ways of working this out. Perhaps the most obvious is to work out the difference between any two numbers on the scale. So for instance, if we take 20 and 16 here, we are asking ourselves, what is the difference between 16 and 20? The way we do that is using subtraction. So 20 take away 16 is 4. So I know that this scale is going up in 4. So by subtracting two numbers that are right beside each other, starting with the big one, subtracting the smaller one, we can work out what the scale is moving up in. But perhaps an easier way of doing it, and you can't do this with every single scale, but you can often do it, an easier way of doing it is looking for a nice round number, for instance 20, and then looking at the number beside it, 24. And we should be able to obviously see here the jump between 20 and 24 is 4. Likewise with this number here, 40. We can see that the jump between 40 and 44 is 4. So this scale will consistently move up in 4s with every increment. Now, using the same strategy again here, I could do 18 take away 12 to work out what the increment is. And the increment in this case would be 6. Or similarly, I can look for a nice round number, say 30 here, or 60 here, and see what number is directly beside it. So in this case, the scale is moving up in 6. I'm going to leave the next two for you to work out as an example, but let's move on to a different type of scale. Now these scales here have missing numbers in between. So we are told what the major increments are, but there are minor increments which we don't know about. And we're being asked what this particular number on this scale is. So, the first thing we want to do is work out what the increments are, what the major increments are. Now we can do it a couple of different ways. I'm seeing here there's a 20 and 24 beside it, so the scale should be 4. The jump from here to here, and here to here, and here to here should be 4. The other way I could do it is I could start with 32 and take away 28, and again the answer will be 4. So I know that the increments, the major increments, are going up in 4s. However, we're being asked what this minor increment is, what this minor scale is. So if the major increment is 4, but there are 2 jumps on the way to getting there, in that case, this number here must be 4 divided by 2. So the minor increments are going to be 2 at a time. In which case, between 28 and 32, we must have the number 30. Now the way we did that was by working out the major increment and then dividing it by the number of minor increments. So in this case, the major increment is 4, but there are 2 jumps in order to get there, so we divide it by 2. Now, we should be able to prove this just by looking at the scale itself. So we see here, it goes 8, then it would be 10, then 12, 14, and then 16, 18, and 20. So we can see that once we've worked it out, we can work out what any of the minor increments are here. Let's use the same strategy here. So the jump between 24 and 30 is 6. Again, we could use our cheat strategy, look at the 30, look at the 36, and it's a jump of 6. So here to here is 6. But again, there are 2 jumps in between each increment. So we're only going basically halfway between 24 and 30. So, in other words, what is half of 6? Or what is 6 divided by 2? The answer is 3. So this is going to be jumping up in jumps of 3. So we're going 24, 3 more is 27. And again, like before, we should be able to actually see that this holds true for the entirety of the scale. So it would be 12, then 15, then 18, then 21, then 24. And it works all the way up as well. So 60, 63, 66, 69, 72. Works throughout the whole scale, holding to the same rule the whole time. We'll do this one down here just for the sake of it, and then I'll leave the bottom one for you to practice at home. So the jumps here are going up in 40s. 400 to 440 would be 40. So the jump from 440 to 480 is also 40. Divide that by 2, because there's 2 jumps. Each jump will be 20. So 440 plus 20 is 460. Now, often, there are even more minor increments than just that. So, in here, we have 1, 2, 3, 4 minor increments in between each major increment. So, sticking to our formula, first of all, we always work out the major increment. So what is the jump between 36 and 40? Well, I could do 40 take away 36, and the answer there is 4. So the major jump is 4. Here to here is 4. But there are 4 minor jumps in between. Okay, so I'm going to have to take 4, and this time divide it by 4, which means each one of these minor jumps must be 1. Therefore, we're going 36, 37, 38, 39, 40. Well, the arrow's pointing at 37, so it's going to be 37 there. So, with this example down here, we're being asked about this particular location on the number line. So, the larger increment between 48 and 56 is a jump of 8. So 56 take away 48 is 8, or I could just be looking at the jump between 40 and 48. That's a bit easier to see it. So the major jump is 8, but we are taking 4 minor jumps between each major jump. So I'm going to be doing 8 divided by 4, meaning each one of these is a jump of 2. In which case we're going to be going 48, 50, 52, 54. So this number here is going to be 54. Again, I'm going to leave the last 2 for you to work out at home. But here's one final example. So our final example here. We're not seeing 4 jumps in between each one. We're seeing just 3 jumps in between each major increment here. So the jump between 18 and 21 is a jump of 3. In this case, there are 3 minor jumps, and so that means that each jump just has to be a jump of 1. So it would be 18, 19, 20, 21. So we can see that this one's 19, a nice easy one there. However, where it gets a little bit harder, or where the numbers get a little bit bigger. The jumps in this one are 150. Now I worked that out by looking at the 1200 and the 1350, and I can see that that's clearly a jump of 150. So from 900 to 1050, the jump's 150, but there are 3 minor jumps here, which means that each one of these is 150 divided by 3. Each one is a jump of 50. So we'd have 900, 950, 1000, 1050. So this number here would be 1000. So what we've seen from this then is that there are 2 steps to working out any scale. First of all, we calculate the jump between the major scales, the major increments. Then what we do is we take that major jump and divide it by the number of smaller jumps. Now, in the next video, we'll be examining how to actually read a scale when it comes to graphs.